So yeah, when I was creating this presentation, I wanted to make it like a typical red teaming presentation and the most boring red teaming talk you ever heard. And that's on purpose. That's on purpose because I wanted to show you that Macs, just like Windows stations or Linux stations, can be attacked with maybe not the same, but really similar techniques. And this is what this talk is about. So if you read the agenda, you'll see the setting up the C2 environment, and then initial access like on any other machine, persistence, data collection. And because this is a purely red teaming talk, I don't want to leave blue teams without any recommendations, so I will also talk about some recommendations on how to harden macOS environments. So why did I decide to make this talk? Because Macs are getting more and more common, even in huge infrastructures. Because we even test banks with Macs connected to Active Directory, because one manager wants to have a Mac or a developer or somebody from the UX team. So Macs are really are becoming more common in infrastructures, and small companies or software houses, there is, sometimes it's majority of Macs in their infrastructures, especially in software houses. So yeah, they are more and more common. And the third thing is that comparing to Windows stations, where everybody knows how to secure them, how to, enforce group policies, etc., usually when Macs are connected to the networks, the company networks infrastructures, usually the security checks, GPOs are not enforced on that machine, so they are easy targets for red teamers. And what are the common problems that we observe during red teams on macOS? As you can see on slides, really simple things, right? Like old vulnerable macOS versions everywhere. I even pen tested or red teamed one huge Polish bank when there was a developer that had Mac outdated for 2 years in bank's infrastructure because there was no MDM enforced on those Macs, and they were connected to Active Directory. So yeah, macOS system firewall disabled because that's the default configuration. So if there you have no group policies enforced on Macs, that's the default setting. Not even saying about EDRs, because still a lot of people think that on Macs there are no viruses. There's the first user account you create when you buy a Mac is an admin account. So if they are no managed, the regulars developer's account is administrative. Not even saying about application whitelisting, so they can install everything they want on their machines. And yeah, what I told you before, in small companies, usually Macs are not even enrolled to MDMs. So let's split Mac infrastructure to 3 scenarios. The first scenario is that Macs are directly bound to Active Directory. That becomes less and less more common because nowadays new companies usually don't use Active Directory, they use Azure or they just don't use it. The second scenario is when the Macs are connected to the AD, but not directly, not by bundling them, but because they have the developers or other employees need to access shares or SSO, so they need to have Kerberos. And instead of bundling those Macs directly to Active Directory, they install something called Nomad. That's an extension that handles Kerberos. So they are not bound to AD, but Kerberos is a plugin that talks through Kerberos via resources of the company. And the third scenario is when, of course, there is no Active Directory, everything is connected directly to the internet, and developers or any other employees use SSO to connect to talk with companies' services, or like AWS or Jira or Google Workspace, Slack, etc. And during this talk, we're gonna focus on such an environment. So we have a Mac that connects via OpenVPN to internal company's network, and via Nomad, the Kerberos extension, connects to Active Directory, and through ADFS SSO gets access to Workspace, Jira, etc., etc. This victim will have AWS credentials saved on their machine, and of course some secrets on desktop, documents, and other protected directories. And this company was told that Firefox is a secure browser, so let's use Firefox. And because there are some services that cannot be bound with SSO, like social media, for example, this victim will use Firefox to connect to those services. And yeah, the same with Signal. The company was told that Signal is secure, so they are using Signal. So in order to attack such an environment, let's create our C2 server. So I choose to use Mythic, and that's an environment that I usually use during red teams because it has really good support. It's fully open source. It's free. It has really extensive documentation, and what I like most about it is that they provide you some Docker images. You run one script on Ubuntu machine, and everything works right away. So that's really good. If you ever created a C2 environment, you know how hard that could be. So they are really good. They provide you a script that does everything for you. So if you set up such an environment, you will have such a console where you can log in. And yeah, the console is really simple. So let's create a payload. We are gonna use upfile, the standard HTTP payload with the profile that is HTTP. So let's create one. Generate new payload. We select the platform. We are attacking macOS, so macOS, of course, upfile. Under the hood, upfile uses JXA, which is, you can treat it as a PowerShell on macOS. So this our PowerShell will talk with our C2 server via HTTP, and we're gonna use the simplest setting that is possible because that's only for the presentation purpose. And as you can see, we can now download the payload, which is a JavaScript file, right? So now we have JavaScript file and treat it like a PowerShell file. That's something similar in Mac world. So now we have to deliver the payload, and the victim has to somehow execute it. So let's talk now about initial access problems. And the first problem is that according to Apple, every software downloaded directly from the internet will have quarantine attribute, which is if you are coming from Windows world, that's like a mark of the web. So if something is downloaded from the internet, that it must be notarized. And if you read what does it mean to be notarized, is that you have to sign the application package or the executable or the DMG file or the file inside of the DMG file with your developer certificate that costs $99 per year, and you have to send this executable to Apple server, and they will notarize it, meaning that they will verify if there is no malware in that file. They will provide a stamp, and they will send you back the file with the stamp. So yeah, what happens if you don't notarize the software? Unfortunately, macOS will block it. There will be a prompt that the application cannot be opened because the developer cannot be verified. So you have to do it. But during red teams, we don't usually want to buy a new developer certificate and notarize it, etc., etc. So we had to solve this problem. So let's talk about the solution. Of course, the simplest solution is to go through the normal process, so notarize the application or the package. But here we risk our certificate to be revoked. So that's not good. The second idea on how we can bypass it is to use the malware's technique. That's a screenshot from real malware on Mac. So on macOS, if you deliver your application in DMG file, that's like a ISO file on Windows, you can set the background. And the background may contain an instruction to user on how to disable their security. So as you can see here, the malware says, okay, so right-click on the package and then click open. And when you do it, there will be another prompt that, dear user, you must be aware that we didn't notarize this application. We cannot assure that it is free of malware. So if you click OK, it will be run, but please be aware that we don't take any responsibility for that. Then, of course, user can click OK or open, and without notarization, without our paid developer certificate, we can run code on victim's machine. But that's the only one solution to that. There is, of course, the third solution, which is a 0-day. In my career, I have found 2 0 days for Gatekeeper, and Gatekeeper is the mechanism that verifies if the application has been notarized. But, of course, that's not really convenient because we still need to have a working 0-day. Or if you're attacking an old machine and you know that the developer or other victim uses an outdated machine, you can just download an old Gatekeeper vulnerability, because there are researchers that are publishing their findings. But as I told you at the beginning, I want this talk to be as boring as possible, so the standard techniques known from other red teaming talks, but for Windows and for Linux. So let's use, who can guess? What can I use like another initial access technique? The oldest dump technique to run untrusted code on users' machines. 3, 2, 1. Macro. Yes, we have macros on Word on Mac. So of course the old trick to read this document, you must enable macros first. Of course, we have auto-open subroutine. So do you know how we use macros on macOS? We use mac script command because Visual Basic for Macs is really broken, incomplete, and buggy, so we don't want to use it. So we use mac script only to escape that retarded Visual Basic as fast as possible, and we are executing shell commands. So that's how we use Microsoft products on Macs. So the thing we do here, we are downloading with curl the JavaScript file. We change the H mode on this to be executable, and with OSA script we launch the JavaScript file. Of course, we use OSA script because, as I told you, that JS file you can treat it as a PowerShell command. That's kind of like that on Macs. But there is one more problem, that on Macs, Microsoft Word is sandboxed. So we have code execution, but the code itself will be sandboxed. That's not a really good thing for us. And of course, there are researchers that published ways to escape the word sandbox. There is a really good article about it. However, it has one minus. The code will be unsandboxedly launched after user reboots their machine. So during red team, it's not really useful, right? Maybe when there is a new macOS version and you are performing a red teaming just before everybody in the company needs to update their machines, maybe then that's okay. But usually it's not kind of useful. So let's use our own 0-day. That's my 0-day that I found some time ago, and that's a full macOS sandbox escape vulnerability. It worked not only for Microsoft Word, but also for whole macOS sandboxing system. So without spoiling how it worked, let's see the demo. So I delivered the malicious file with macro to the user. The user double clicks on it. Of course, there will be the prompt to enable macros. And in the moment, you will see a new active callback from my machine. And now let's execute shell commands to verify if we are unsandboxed. So let's use who am I. So that's my user, that's good. And now let's see if we are unsandboxed. So just list users directory, and if it succeeds, it means that we are unsandboxed, right? Because we can read other users. So yeah, we see the shared directory. That means that we successfully managed to escape from the Microsoft Word or just macOS sandbox, because that's a 0 day for the whole sandboxing system. And if you take a look on how the 0 day worked, it was really simple. In the past, sandboxed applications could have open unsandboxed applications with passing them environment variables. And I reverse engineered macOS terminal, and it turned out that if you set OS install environment to 1, an environment variable, you can define an arbitrary path that the terminal will use. And as path is executed by shell, right, because it's loaded, I could, inject any command that would be executed within the terminal's context. So that's how I achieved the unsandboxed code execution. All right, so now we can treat, I think, that we perform the initial access. So right after every red teamer gets the initial access, we need to do persistence, right? So how one can achieve persistence on Mac? We can use the standard launch agents, launch daemons, login items, cron jobs, authorization plugins, but there are many, many more ways to do it. So let's use the standard launch agent technique. So we use persist launch command in Mythic. And now just like register a new launch agent with the OSA script. We can set up any label we want. Let's come Apple something, but we can change it to anything. Let's wait a moment. And yeah, it has been submitted, so the file was created. Now when we created the launch agent, we need to register it. So to register a launch agent, that's really, really simple. So we are just loading it, and that's it. And after a while, you will see that we have another callback. That means that our new launch agent has been registered and talks with our C2 server. Yeah, so we can see the second callback. So I think we can say we achieved persistence. However, because this presentation is about problems, right? So another problem, whenever anybody registers a new login item on macOS Ventura and now on macOS Sonoma, there will be a prompt that login item has been added. And during red teaming, we'd like to skip that part, right? We don't want to inform user that something achieved persistence on their machine. So I thought for some time on how can we bypass it. And I think I can share another 0 day with you, and that's truly a 0 day. It has not been fixed by Apple, so it still works. What I'm gonna to show you. So we are assuming that we perform the initial access with PKG file, and we usually want to do it like that with PKG file, because whenever a user installs a PKG file, we have root code execution, because PKG files are installed with root permissions. So if we have root permissions, and that's the typical way how we do it, we just create an invisible HAL driver. So that's a driver and core audio daemon. Core audio daemon executes and is responsible for handling sound on macOS. So as you may guess, where the HAL drivers are loaded, right after system is loaded, because the voice daemon must be loaded as well. So all our drivers will be loaded as well. There is one problem, that HAL drivers run within the core audio daemon process, and core audio daemon process runs as core audio daemon, core audio user, and we want to be root, not core audio daemon. So it's really simple. Just do it in 2 steps. The core audio daemon, the malicious plugin, will launch our application with solid bit, and that's it. So we just, and that's the whole driver. It's really simple, as you can see, 11 lines. It's a empty completely driver that the only job it has to do is to load our loader. And the loader works looks like this. It just loads the JavaScript file we created, the payload we created with Mythic. And we bundle it within a package file. So as you can see, this is the driver we are placing on victim's machine. This is the payload we created, the malicious code. And because we are delivering a package file, it's just like on Linux. We can create post-install actions. So the post-install actions are just, giving the appropriate permissions, like the hmod, like the owner of being root. We also change the flags to hidden, so user cannot see the malicious code without specifying some flags. And of course, at the end, we are killing the core audio daemon. So the new driver, our malicious driver, will be reloaded, right? Because the core audio daemon must be reloaded as well. So yeah, that's how the zero-day works, and that's really zero-day. It will not trigger the prompt. You have persistence, and it's still unfixed. So if you'd like to use it, feel free. So I think we can say now that we successfully managed to compromise the machine, to do the initial access, we have persistence, and we have root permissions. So we have everything we wanted to have. Now let's collect some data. So we are interested in VPN credentials, Active Directory credentials, signal messages, browser cookies, or password saved within browsers, keychain entries, cloud keys like AWS, Google Cloud, maybe Azure, maybe SSH configs, and the restricted files on desktop or documents. So now let's focus on OpenVPN. If you go to OpenVPN profiles, directory, and library application support, you have the whole profile. But nowadays, nobody stores passwords within the OpenVPN profiles, right? That's not like 90s. So usually when companies deliver OpenVPN profiles, user must authenticate with their user and password, right? With their username and password. And it's not stored within the profiles, as I said. And on macOS, there is really important thing to understand before you start attacking applications. Even if you are root, you cannot debug other processes when they are properly signed. To do it, you have to disable system integrity protection, which is not recommended. Usual on typical macOS, you cannot debug other applications even if you are a root, unless developers give their applications special permissions that will allow that. And OpenVPN developers did it. So they, on purpose, I don't know which purpose it was, they are giving the OpenVPN two insecure entitlements. Allow delete environment variables, so you can use LD preload to inject code, to inject a dynamic library to the OpenVPN's body. But macOS will verify if this dynamic library was signed with the same certificate. So only this one entitlement doesn't give us much. However, there is the second thing, disable library validation. So they on purpose gave the OpenVPN possibility to just completely ignore signature. So it means that you can load anything you want to OpenVPN process without any additional permissions. You don't even have to be root to do it. And that's how I do it. That's a keylogger I've created for OpenVPN. Everything I code, I'm sharing on my GitHub. So this all is open source. If you want to reproduce it on your machines, go to my GitHub and you will see the code. So the tactic is simple. We use build insert libraries, which is like a LD preload on Linux. We inject the keylogger. We disconnect user from their VPN, and we sniff for the password. So that's it. Okay, so I think we can treat. We successfully managed to get OpenVPN profile and user credentials. So now we need to get the Active Directory credentials from Nomad, because Nomad is the Kerberos extension, so we must have the Active Directory login password, etc. And in 2020, so 3 years ago, I wrote a blog post that there is a problem, architectonical problem on macOS with storing entries in the keychain. And under some circumstances, any application may get those entries. And unfortunately, Nomad passes this circumstances. So I created a tool that I named Nomad Credential Stealer, which is really simple. You just download my code from my GitHub. You run the Nomad Credential Stealer without any flag or anything, and your Active Directory username and password will be dumped. And that's it. No additional prompts, no root, no anything. Just use the tool and you have Active Directory credentials. So that's really a huge thing, right? And as we have Active Directory credentials, we have access to company's internal network. We can get access to Jira, Workspace, and everything that's hidden behind the SSO, right? Because when we can create Kerberos tickets, we can connect to Active Directory Federational Services, so we have the SSO tokens, and now we can go straight away to all the company services. So that's it. Okay, so now let's focus on Signal. Who thinks that Signal is secure? Okay, so not many hands, but you know, this presentation, you know that I will be showing some problems, so you didn't want to raise your hands. But let's answer one question. When Signal claims that your data is protected, your messages, photos, video calls, when Signal claims it's protected? In transit, yes, that's correct. They don't say that data on your machine is protected. That's an end-to-end encrypted chat, so the transit is protected. But messages on both sides stored on their machines are completely not. But Signal decided to put all your cookies, messages, photos, etc. to SQLite-free databases. And this SQLite-free database is encrypted. However, you may ask, where is the encryption key? Next to the database in config.json file. It's not even in keychain. It's in a flat file. I reported it to Signal like 4 years ago or something, and they told me, yeah, but we don't care about your data on your machine. We only, give you confidentiality that during the transit your data is safe, not on your machine. So yeah, that's how Signal is secure. If you have it on your Mac. So you go to library application support Signal, and there is a config.json file. If you have Macs, you can check it, and there will be a key. They didn't even, put it in system keychain. That would change a lot. They are just next. They are, lying next to the database file. Okay. So now, let's attack Firefox. So now, who thinks that Firefox is secure? Well, it is, to be honest, a really good browser. I used to use it in the past, But there is one problem. Like, Firefox stores login and password in encrypted form. And there is something called master password. That usually is not set because it's not set by default. And now you may raise your hands. Who even heard about master password on Firefox? Okay, I would say that's a good result. Usually when I ask such a question, maybe one person raises their hand. So you are quite aware, security folks. But even some years ago, I didn't heard about master password. So I think like maybe 35% rose their hands now. So if you know what the master password is, who has the master password set? Okay, now the result is a bit worse. But what master password does, it derivates a new encryption key. So before your browser may autofill your login and passwords on websites, you must provide your master password to unlock the let's say the keychain of the saved password. If their master password is not set, you can use not my tool, but tool that's called Firefox Decrypt. That's a simple Python script that works like that. And it will get all the passwords from Firefox without root or anything special. You just select the profile and you dump password from Firefox. That may do any application with standard user permissions. No root is required here. Great. So we have Firefox, we have Signal, we have Active Directory. Now let's focus on AWS keys and files stored in desktop or in documents, etc., etc. So on macOS, there is a mechanism called TCC, Transparency, Consent, and Control. And whenever an application wants to get access to some privacy-sensitive data, like address book, like camera, there will be a prompt. And the thing is that even if you are a root, you cannot bypass this prompt. If you can, it means that you found a 0-day, you can report it to Apple, and Apple pays well for such bypasses. So even if you are a root, you cannot bypass this prompt, or even if you programmatically can move user's mouse and click the OK, that won't work. That's called synthetic clicks, and Apple also blocked this technique. So if we want to get access to some desktop files or documents, or take a screenshot or make a selfie of the user, we have to somehow bypass it. And nowadays there are a lot of resources that are protected by Apple, even like Bluetooth access, network shares, pen drives. Almost everything that's related to user is now blocked by operating system, by the TCC. So we need to somehow bypass it. But let's see if we try to access user's desktop from Mythic. Let's list files or documents on desktop. Let's see what will happen. So just simple ls desktop. You see, the prompt is being raised, and when user clicks don't allow, the operation will not be permitted, and it will, it may scare a user. So we don't want to do it when we are doing red teaming, right? Because the user may trigger an alert in SOC or something. So we want to skip it somehow. So in the past, there were a lot of TCC bypasses. Me with my friend, we've made 2 Black Hat talks about it. The first Black Hat talk was 20+ ways to bypass your macOS privacy mechanism. And 1 year later, we made another that was in Las Vegas, and then 1 year later, we've made another talk in Black Hat Europe in London, and it was called 20 new ways to bypass macOS privacy mechanism. We found a lot of TCC vulnerabilities. So of course we can use a 0-day, but it's still not really useful during red team. So we can abuse permissions of currently installed applications like Microsoft Teams or Visual Studio Code, etc., etc. And this year I made a talk about it on DEF CON in Vegas. So if you are interested, Google for Electronizer. I made a tool that does it automatically. It's also free and open source. But if you take a look at my blog post, you will see that I pointed this problem in 2019. And to this time, Apple did not anything with that. So yeah, you can still abuse other applications to get access to TCC stuff. However, let's take a look at another technique. Usually Macs are enrolled to MDM, and usually they have SSH enabled, and the SSH has something called allow full disk access for remote users. And that's an ultimate TCC permission. So whenever a process has full disk access, it means that it may access everything with completely ignoring the TCC. So we can access desktop, camera, etc., without triggering TCC prompts. But yeah, that's only for SSH. So maybe, who can guess? Well, how can we abuse it? We have code execution on user's machine. Yeah. Yes, that's it. So we don't know the user's password, so let's create a SSH key. As you can see, we cd to desktop, operation is not permitted, so let's now bypass it. We do SSH key again. We override the old one. Just copy it. We need to change the H mode, of course, because that's SSH requirement. And now SSH to localhost. Connected. And now let's go to desktop. And we have access to desktop. So it means that we ultimately bypass the whole TCC idea, because we just connected to ourselves by SSH that had full disk access. All right, but that's about the files on desktop, documents, etc. What about cloud keys, SSH keys, AWS, Azure, G-Cloud, and other tools? They are lying in the home directory, which is not TCC, which is not even TCC protected. So without bypassing TCC, we can just access those files. So no root, no anything is required. And I think that made this presentation complete, as we got access to all the resources that we wanted to access to on Mac, right? So let's now talk a bit about hardening macOS environments, and those 6 points are the bare minimum. So of course, enroll Macs to MDMs like Jamf, Intune, or any MDM you want. I'm not promoting any of those. Keep them updated, because as I showed you, Macs can have viruses. There are 0 days. I even published one. So you must have your Macs updated. And for security policies, especially system integrity protection must be turned on. Because if you Google for some problems with macOS and you go to Stack Overflow, you will see that usually one of the highest rated answers is, okay, dear Stack Overflow user, this doesn't work, but if you disable system integrity protection, everything will work. And a lot of people do it. And when system integrity protection is turned off, like no security controls are enforced on Macs. TCC doesn't work. You can be root without providing user's password. Like no security protections are enforced, so you must be sure that system integrity protection is turned on all machines in your infrastructure. And as I say, go to Stack Overflow, search for any macOS problem, and one of the highest rated answers will be disable SIP, and everything will work. Yeah, it will work, but the whole security will stop working, so that's why everything will work. Disable Office macros, because I guess even if you have Macs in your infrastructure and you have Microsoft Office applications, who of you uses Visual Basic for applications on Macs? I don't know such people. Even accountants, of course, they usually use macros, but they are on Windows stations, not on Macs. Usually. Maybe in your components it's different, but I can bet that in most cases, macros can be turned off right away. Install, of course, an anti-malware solution and monitor your Macs, because you cannot know about everything, about every 0 day, etc. Because yeah, macOS also have it. So if you'd like me to take a look at your infrastructure, or you would like to perform a red teaming, you know how to reach me out. I have Twitter, LinkedIn, or just after the conference, as you want. And just a quick sum up, because I wanted this presentation to be as normal as any red teaming talk is. We went through all the steps that are required to do a successful red teaming exercise. So the only thing I want you to remember after this talk is Macs are like any other computers that may be attacked. There are vulnerabilities on Macs, so monitor them, install EDRs, and keep them updated. That's the most important things. Thank you very much. Do we have time for questions? 1 minute or what?
Yeah, 1 minute.
Anybody has a question?
Did you try this scenario with EDR enabled? Did you try this scenario with EDR enabled?
Yes.
And
works. Everything. Like usually EDRs don't care about injection to other applications, and those were the most useful case. Of course, if EDRs are, if they have logging mode, such events will be logged, and that's nowadays your SOC will know about it. But that's the problem with the detections on macOS. There are no, many people then can do that they will understand on, what happened on the Macs, because usually it's about providing an additional environment variable to the application, right? Or loading a new library. And the problem is that, for example, Firefox loads unsigned flash binary still to itself, and that's a normal event. So if you have unexperienced, for Macs, of course, people in your detection team, like they will see such events a lot of times, like triggered by regular applications. So yeah, of course, we do also training for detections and such things. So. Okay, so thank you once again.